Welcome back to the channel. Please remember on this channel, friends, I post math videos, but usually at a more advanced level. In other words, something a bit more abstract. So we're going to do an open box problem, but we'll keep it a bit more abstract than the usual. So we're going to say an open box is made by, again, removing a small square. So that seems very likely familiar, a small square from each corner of a, say, tin sheet. And then we basically fold up the sides and we make a box. You've seen that picture before. So the only difference is we're going to have a parameter instead of a particular value. So if the sheet is L inches, so usually here we have a specific numerical value, not this time, on each side. What is the largest possible volume of the box? That's our goal here. Okay. So first of all, perhaps it does help if you sketch a picture out, at least from a perspective above the box. Roughly looks like this. It's square because each side is L by L. That means this is originally L. Keep it capital L. Then when you cut a corner out, then of course what happens is this corner gets cut out. Let me zoom in here. Okay, and then this corner here gets cut out this way. Let me pull this down. So then of course this is X and then this is X right here, which means what's left over in the middle, which is this side. That's the effective side you're folding up to make your box. Since, keep in mind, this whole thing is L right here, okay? So let me move the L into this position. Give me a sec here. This whole thing is L. Then you cut an X from the top and an X from the bottom, which means the inside is L minus 2X. And because it's square, it's like that on all four sides. So that part is finished in terms of a nice sketch. Let's continue then. So what's the volume of the box as a function of x? V of x would be equal to x, because that's the height of the box, the size of the corner. And then it would be L minus 2x, because that's the length of a side. And then L minus another 2x. So in other words, here, when you cut this corner out like this, then the same principle applies, which is that this would be L minus 2x here, left over, right? Because this would be another x cut out here. And this would be another x cut out here this way. Then from here, let's say we have v of x is equal to x. And it's L minus 2x, but it's there twice. So you can FOIL it out. Let's do it. So it's going to be L times L, which is going to give us L squared. L times negative 2x is going to be a negative 2xl. And then minus another 2x times L, so a minus 2xl again. And then plus negative 2 times 2 is a 4. And the next times x is x squared. Let's write this out a bit more neatly still. So x, and then clean that up. It's going to be L squared minus 4xl plus 4x squared. Now let's distribute the x and write it so that the exponents decrease. So it's going to be 4x cubed this way, and then minus 4x squared L, and then plus xl squared. This is our function for the volume of the box. So now let's differentiate this as usual. V prime of x. Remember, in this context, when you differentiate, the L is to be treated like a constant. That means you differentiate with respect to x. 12x squared minus 8xl, and then plus L squared at the very end. That's our derivative. Now we have a nice factorization question, really. So perhaps you can do the factorization mentally, but if not, then what you can always do is remember the following. You can do the 12 times the L squared like this. So we have 12L squared, correct? In other words, what we're going to look for are two numbers that multiply to 12L squared, or two expressions. And the same ones will also then add up to negative 8L. So here in the middle, put this way, because negative 8L is the coefficient, you see? Okay, so try these. For example, you can do 3L times 4L. Well, let's see, that's going to give us 12L squared for sure, but it's not going to add up to negative 8L. So this is no good. Okay, so try a different combination. See what happens in that case. Say 6L and 2L. That doesn't work because it does give us 12L squared, but it doesn't give us negative 8L. Okay, so then flip the sign. So write this as negative 6L, like this. And then write that there as negative 2L. Does that give us what we need? So multiply them. That's 12L squared. That's good. And then last, also, when you add them, you're going to get negative 8L. That's good. So now let's factor v prime. So v prime of x is going to give us 12x squared. Replace negative 8lx with negative 6L and then negative 2L and then x also. So for example, you could say negative 6lx minus 2lx and then plus L squared at the very end. All right, continue down below here. Between the first two terms, it looks as though 6x is a common factor. What's left over then, of course, would be 2x, because that multiplied by 6x is 12x squared. And then what's left over at the end would be the 6 is out, the x is out, so there's an L left over this way. So 2x minus L. Now, for the other two terms, it looks like maybe we can factor a negative L out, but that's about it. So that means we're going to be left over with 2x plus L, and this has to be a negative now, so if you distribute the negative back across, it would make it back into a positive. So now we have our 6x minus L, and then we have our 2x minus L left over. You can check that this factorization works correctly. Now, based on these, take a look. Let's continue over here. So I will say 6x minus L is equal to 0. So if you solve this, x would be equal to L divided by 6. Whatever L happens to be there. And then for the next one, I would have 2x minus L would be equal to 0. So that's going to give us 2x equals L divided by 2. So x is L over 2. There you go. So those are possibilities. All right. Let's put these on a number line. L is the same numerator in both, which means L over 2 would be bigger than L over 6, because dividing by 6 makes smaller pieces than dividing by 2. So we have this. In other words, the L minus 6 has to be essentially to the left of the L over the 2. Now what happens, for example, at L over 2? Let's think about that, okay? So go back, say, to the original function for the volume, or take even the side, L minus 2x, right? Take a single side. So L minus 2x, so 2 times L over 2, like that. Replacing x with L over 2. So the issue is that the 2's will cancel, and you're going to end up with L minus L, which is 0. In other words, this is a flat, thin sheet. There's no volume made. It doesn't have much practical value. Okay, so then let's look at what happens at L over 6. So you'd have L minus 2 times L over 6 this way. Well, what do we get in this case? We're going to have L minus L over 3. So 2 and the 6 cancel off a 2, leaving a 3 in the bottom. So that's going to give us 3L over 3 minus L over 3. L over 3, that's going to leave us here with a 3L minus L, which is 2L over 3. That's the length of a side in that case. Now also notice if you take, say, L over 12, that would be to the left of L over 6, okay? And then maybe take like an L over 5. That would be to the right of the L over 6. And then let's look at what happens when you plug L over 12 into the first derivative, right? So 6 times L over 12 and then minus L. And then you're going to multiply this by 2 times L over 12 and then minus L. And then you work through this expression, trying to determine its sign. So that's going to give us here, let's see, it's going to give us L, so cancel off a 6 and a 6 top and bottom there. So it's going to be L over 2 minus L. And then same thing with the other one. So we're going to have canceling off a 2L over 6 minus L. And then we continue here. How do we do this? Well, let's see. It's going to be L over 2. We write that L as 2L over the 2, right, multiplied by L over 6 minus 6L divided by 6 this way. Let's see what happens in terms of the sign. So you're going to have L minus 2L, which is going to be a negative L over 2. So it's negative. And for the other one, it's going to be L minus 6L. So it's going to be a negative 5L over 6. So the point is you're going to have two negatives and then the 2 and the 6. You're going to end up, in other words, with a positive 5L squared. And then that's going to be divided here by 12, right? This is greater than 0. Why do we need to know that? Because it's telling us that this derivative here is going up to the left of L over 6. Let's repeat this for L over 5. So let's see what we get in that case, friends. Okay, so we're going to have here 6 times L over 5 minus L over 5 here, not 6. And then you're going to multiply by 2 times L over 5 minus L. Okay, again, that's the first derivative being evaluated at L over 5. So you're going to have 6/5 of L minus 5L over 5. We write it that way. And then after that becomes 2L over 5 minus 5L over 5. Then you work through that. So it's going to be 6L minus 5L is going to be an L over a 5. And then 2L minus 5L, that's going to be negative 3L over a 5. Okay, finish this up. So then it's going to be, you just multiply them. So that's going to give you negative 3L squared over 25. This is a squared quantity, right? This is, in other words, less than 0, which means that the first derivative is going down, which means L over 6 represents a maximum value for our answer. So that means basically what we have is x equals L divided by 6 maximizes the volume. What is the maximum volume? That's the next question. So let's see. We got to evaluate, say, this expression right here. Let me punch it down. In other words, x equals L over 6, and then this is our v of x right here. So let's evaluate. Let me just pop things over a bit more this way. Okay, so let's do it. We're going to have L over 6, and it's going to be multiplied. And I believe previously up here we found that L minus 2 times L over 6 was 2L over 3. So you're going to multiply by 2L over 3, and then you're going to multiply by another 2L over 3, and that's V of L over 6, basically. So let's work this out. So it's L times L, which is an L cubed, and then you have 2 times 2, so it's going to be a 4L cubed, and in the bottom you have 6 times 3 times 3, so it's 9 times 6, which is 54. And then this becomes, in other words, V of L over 6. In other words, we would say V sub max, the maximum volume, is that 4L cubed over 54. But then let's just divide the two away. So we're going to have that V sub max, the maximum volume possible, is 2L cubed divided by 27. And that's the answer. Please leave a like and subscribe if you like math videos at this more advanced and abstract level.